RF Man here. This is part 4 of my 4-part series on long wire antennas, 9-to-1 Ununs, RF chokes, and antenna tuners. In this final section, I'm going to talk about the antenna tuner, the different types, and how I constructed mine. And then we're going to go ahead and add all the components to the antenna system and test the system with a couple of different radios. So here we have actually 3 basic designs, and a little caveat to that would be there's a lot of variations of this, so I'm just going to show the 3 basic designs, but you can do a lot of research on the internet and see all the different variations. But the first one is the familiar L network, where we have an inductor in series and then a shunt capacitor. And depending on the impedances, the capacitor can be placed before the series inductor or after the series inductor. So in this typical configuration, you're going from a low impedance, which is a radio, to a higher impedance, which would be the antenna. And of course, we're trying to tune the antenna so it's at resonance for the frequency that we're using. So this is just your simple basic L network. Okay, the next configuration is called a T network. Okay, and here you have your 2 series capacitors, and of course they're variable, and a shunt inductor, which is also variable. A lot of times you'll see roller inductors used and air variable capacitors, and the higher the power rating, the higher the rating of the individual components. For the inductor, it would be the gauge of wire used and the spacing between the wire, and for the capacitors, it's the size of the plates, but more importantly, the air gap in between the plates. If the capacitor isn't rated high enough, you'll actually get arcing, you'll get RF energy between the air gap. But this is the other version, okay, and this is called a T network for the simple reason it looks like a T, okay. And as far as the values go, the wider the range of the capacitors, the variable capacitors, and the wider the range of the inductor, the more tuning range you're going to have. And typically the T network, and what I'll show here next, would be the pi network. Just bear with me a moment. Okay, this is your pi network. These have a wider tuning range than the L network and are actually a little easier to tune. So in this case, we have a series inductor. It's a variable inductor, and then 2 variable capacitors. So now if we take a look at my homebrewed antenna tuner, you'll see I've got the 2 variable capacitors there. These are quite large. They're rated for about 2,000 volts each, and again, that has a lot to do with the construction, mechanical construction and design of these capacitors, and also the air gap, which you can see is quite wide there. Okay, and you also see the second capacitor there. It has a little lower rating, but very close. Okay, and then we've got the inductor there. I used a fixed inductor. I was trying to keep my costs down. This is a very effective way to build and wind a variable inductor. Basically, I used a 2.5 inch piece of PVC, and this is PVC-C, so it has a higher temperature rating. And you see the copper wire there. It's a 12 gauge copper wire, okay? It's just bare copper, there's no enamel coating, okay? And what I did is I used these grommet strips. Let me take a closer view of that, okay? These come in 12-inch lengths, and I use these for 2 reasons. One, to space out the winding, so you can see that it's very easy to get it uniform and tight. And the second is it holds the copper wire up above the PVC pipe. It helps with the cooling. I'm not sure I'm going to need to put a fan in the final version of this when I put it inside my enclosure. Um, but it does hold the wiring off the PVC, and it makes it very easy for me to select different windings. Now, what I elected to do in this version is just to manually move the wire, okay, to select the different inductance values, okay. Of course, you can also put a selector switch in and run each of the windings to the selector switch and then use that switch to select your different bands. So what I do here is I got a clamping device here, and I just move that along the winding, the coil, and I select the different frequencies and different bands, and then I go ahead and tune with the two capacitors. Now, I started with an L network, okay, so this capacitor, and I tested that, and it worked. I couldn't get all the bands tuned in, and it was difficult to adjust. So I set this up so that I could easily configure this. You see these terminal strips here and here, and the way I have the wires terminated, I could quickly rearrange this to try all three configurations and asking myself what's going to work best. Now, what you'll see on a lot of commercially available antenna tuners, you're going to see they use a T network. All right, so I started with the L. Okay, I knew that would have some limitations in the tuning. And then I went ahead and I tried the T, and again, just a quick rearrangement of the terminations with the terminal strips, very easy. Quickly switch the ground over, the grounding configuration, and I got myself a T network, and then do the same thing with the Pi network. And I ended up testing all three versions on my antenna system, and I found for me that the Pi network actually worked the best. I had more tuning range. I could get very, very close on all the bands. This will tune from 160 to 10 megahertz. And not only did it have more range, but it was also easier to tune. And most of you are probably familiar, either have an antenna tuner or watch someone on YouTube, but you're kind of alternating back and forth. Okay, you get this one close, and then it starts to increase. Then you go over to this one, and you alternate back and forth till you try to achieve a one-to-one SWR. And of course, I'll demonstrate that a little further in the video when I actually have this connected to the antenna system. I found that grounding is important, so it's a little bit with RF, a little bit of trial and error on the grounding system that's used. I tried to go with the general rule that we use in RF would be single point grounding. So I've got the grounds terminated here, and then I'll show you there. The grounds terminated right here, and then I bring in my earth ground as well. So I try to reduce the grounding loops, and some of that is just trial and error and a little bit of experimentation, to be honest with you. But if you have too many ground loops, it can cause a problem. So try to go with single point grounding and minimize the number of grounds. And when I put this in the metal enclosure, I suspect that I'll be making some small adjustments to it to get it to perform the way I'd like it to perform. So that's basically what it looks like, and it works very well with the 9-to-1 Unun, and with the radios I have and I tested. I've got a Striker 955 HP. I've got another Icom 735. They do not have built-in tuners, so I use this. And I'm also going to demonstrate with the 9-to-1 Unun the Kenwood radio I have, which has a built-in tuner. So we'll have all three of those demonstrations, and you'll be able to see. I'll be using the internal SWR meter in the radios and also an external one. And they correlate pretty close. I've used this now for quite some time. And I thought before I put it all in the metal enclosure, I'd make a video and just discuss the construction. and demonstrate it this way, and then I'll ultimately get it into a metal enclosure. So what I did is I used my antenna tuner first, and I got the range, what number coil I need for what band, okay, and I made a little chart, and so I manually move that and clamp it on, and then I tune. So I've already done that work ahead of time with my antenna analyzer. Gives you a head start on what winding you have to use, and then from there you can tune it in. So this was the final configuration that I went with. You'll find, again, a lot of the commercial tuners like Palistar, they use a T-network, a lot of them. But I found this to be a little better. So next part of this video will be actual test with a couple of my rigs. All right, so now I'm back, and as I said earlier, we were going to go ahead and test the entire antenna system. So I'm going to start with my Icom 735. It does not have a built-in antenna tuner, and I'm going to test various bands. I'm going to start with 40 and then work my way up in frequency. So there's my Icom. It does have a built-in SWR meter. I also have an external SWR meter, a Daiwa, so we can go ahead and compare. They do correlate fairly close. I'm going to do this at about 20 watts or so. Since I don't have the antenna tuner shielded, I'm going to keep the power level fairly low, but get the same results with the higher power level. So there's my radio. There's my external SWR meter. There's the antenna tuner, and you can basically see it's connected to the coax. I've got my RF choke, my 9 to 1 Unun, and my long wire antenna or random wire antenna in the attic. So everything is kind of above us, and I set all that up a little earlier today. So now I'm going to go ahead and just in AM, I'm just going to key up shortly, briefly, and we're going to go ahead and see what the SWRs are. Okay, this is a cross needle meter, so it's where the two cross. It's about 3 or so, so it's quite high, and I can go ahead and use the transmit button here too. Makes it easier. So we'll go ahead and see what we can do to tune this down. So here we're at 3. I'm just going to alternate between the two variable capacitors, and let's see what we can do to get this to drop off. It's coming down nicely. You just got to alternate between the two, and yeah, there we are. It's about a 1-to-1 SWR, which you can see there, and that does in fact correlate with the radio as well. I'll try to get a shot of that. We'll go ahead, and I have a transmit button here, which is kind of nice, and you see the SWR meter there, and the second one from the bottom, and we'll go ahead and put it in transmit mode, and you see the interval. So pretty easy to tune with the Pi configuration. As I said, just alternating between the two variable capacitors. I'm going to go ahead and set this up now for a higher frequency. All right, so now I'm back. We're on 14 megahertz, which is the 20 meter band. And let's put it in transmit mode and see where the SWRs are. Looks like about 2, a little over 2. Okay, so let's go ahead and see if we can tune that one in. Just again, alternating between the adjustments here. And there you go. Looks very close to 1-to-1. And if we check the radio SWR meter, also says 1-to-1. All right, so we keep doubling the frequency. 7 megahertz, 14, so let's go ahead and try 28, which would be the 10 meter. Alright, so now I'm on 28 megahertz, which is the 10 meter band. And we'll go ahead and see what we can do here using the transmitter button. You can see the SWRs are about 3. And now we'll just, as we alternate between the two capacitors, you can see here I'm just adjusting back and forth. Try to get this as low as possible. And yeah, I think that's about a 1.1 to 1. So as you can see, it's able to tune across the high frequency band. Pretty wide range, easy to tune. Now, what I mentioned before is with my antenna analyzer that you see there, I have a SARC 100. I was able to determine what winding I should use for each of the bands. So I set that up ahead of time. I just have a clamp there. You can put a selector switch in as well. I might add that later on, but usually I stay on one frequency for a pretty long time, and I don't switch over that much, and it only takes a minute to just reposition. And this gives you the same flexibility as a roller inductor, because you can position this clamp anywhere around the coil, front or back. So you can really fine tune it if you spend enough time with it. So there's one other test I want to show. Let me set that up and we'll take a look. Alright, so the last thing I wanted to show is my Kenwood. It's a TS450, and this does have a built-in tuner available. So right now I'm just using the 9-to-1 Unun, and that's able to transform the impedance of my long wire antenna down to an SWR that's within the tuning range of the radio. So let's just take a look at this. I'm at 21 megahertz, so 15 meters. You can see the SWRs there, 1-to-1. As I go through now and increase the frequency, you'll see the auto tuner come on. So let's bring it up to, let's say, 20 meters. You can see the light on the auto tuner. So each time I'm changing the frequency, it's tuning. Okay, so there we got 14.1, so we're on 20 meters. And you can see I've got about a 1.2 to 1. So just using the 9-to-1 Unun, which does the impedance transformation for us, I'm able to tune across the whole high frequency band using the auto tuner in this particular radio. So that's it. That concludes the video. I hope this was helpful and useful. RF Man. Thank you.